This is G3b, and in this lesson we're going to look at a couple of different things. Determine first triangle congruence. Then we're going to look at this word prove, and then we're going to look at this word right here, similarity. And it says other properties of triangles. So what we're going to do first is we're going to talk about how do you determine if two triangles are congruent. Well, specifically there are four ways. Let me show you some. Let's pretend that we have two triangles like these two have on the screen here. In order to definitively prove that they are congruent, you would have to say, look, this side is congruent to this side is congruent to this side is congruent to this side, this angle is congruent to this angle is congruent to this angle is congruent to this angle. Wow, and that just gets to be a lot of work. That's 6 different things that you have to prove to be sure if the triangles are congruent, if they are exactly the same. Well, I have good news for you. You do not need to show all 6 parts are congruent. In order to determine congruency, in order to know that they're congruent, there are 4 shortcuts, which I'm going to show you right now. The first shortcut is called SSS and stands for side, side, side. What this means is, if you focus your attention right up here on the two triangles, what this means is if you can show that all 3 sides in the triangle on the left are congruent to their corresponding sides on the right triangle, then what that means is the triangles are congruent. We call this a shortcut. The shortcut's again called SSS, and it works every single time to prove two triangles are congruent. The next shortcut is called SAS, and what that stands for is side, angle, side. Let's focus our attention on the triangles up here. I'm going to start right here. There's a side congruent to a side, an angle congruent to an angle, and another side congruent to another side here. This angle right here is called the included angle because it is in between the two sides. Alright, and you're going to need to identify the different scenarios based upon what combination of sides and angles you have. Again, this shortcut is called SAS, and it does work to prove two triangles are congruent. Third one is called ASA. This shortcut is known as angle, side, angle. Take a look at this side and its relationship to the two angles. We call this the included side. This one as well. So if we start here, we have an angle, a side, an angle congruent to their corresponding angle, side, and angle here. This is a shortcut, just like the previous two, that works every single time to prove that two triangles are congruent. Last shortcut is called SAA, stands for side, angle, angle. And if you look really closely at the triangles at the top, you will see the difference between this one and the others is the position of this side. We call that the non-included side. The non-included side is not in between the two angles. SAA works as a triangle shortcut for proving two triangles are congruent every single time. Next, we're going to focus our attention on this word right here, prove. That automatically should mean something to you, that we're going to be doing proofs and reasons. I'm not going to do a proof here, but if I were to give you an example like this, this is triangle ABC, this is triangle XYZ, and your proof may give you some information to start with, and what you have to do is prove that the two triangles are congruent. And you would do that by saying some sides and angles are congruent to each other, and hoping to eventually get to use one of those 4 reasons: SSS, SAS, ASA, or SAA. And you may very well, on the end of course assessment, be given a problem just like this, where you have two triangles, and you have to actually write out a proof where you are showing or proving that two triangles are congruent. Continuing on is the idea of similarity, that this means that their sides are proportional and their angles are the same. So all the shortcuts for proving congruence also prove similarity. However, there's one more that we need to add. And for similarity, the one more is called AA, which stands for angle-angle. Basically what that says is if there is two angles in two different triangles that are congruent, then the two triangles are similar. That leads you to be able to say that they're proportional and whatnot. And so what are the kinds of things that the end of course assessment might ask you, or exactly like the other problems we've already talked about. Rather than proving that triangles are congruent, you may be asked to prove that triangles are similar. All right. Another thing that could happen is that you could be asked for finding a side length in a triangle or an angle measure in a triangle. For instance, if we have two triangles and we're given the information that they're similar, and we know that this side is 6, what would this side be? Well, if I know the ratio is 2 to 1, I know it has to be double. So this has to be 3 right here. And that's how you use similarity and the shortcuts to prove similarity in triangles. So again, take a look at the different scenarios, the different kinds of problems that I've shown you here. Get some practice with some proofs, because this is a great. In fact, if I could promise you that what one proof would show up on the end of course assessment, I am positive that this is the one that would show up.